Welcome to Ask and Learn.
We're talking about investigating the properties of a large industrial solenoid. And we connect the solenoid and resistors in series with a battery. We have switches, allow the battery to be replaced by a short circuit across the solenoid and resistor. So we're given some information here, and we've got some high-speed switches, and we measure time. Now I've got to go to another page here, so excuse me on this. I'm going to go way over here. Sorry about this. These are some things I want to do later. I just got to keep track of what page I'm on now. 52, this should be it. Okay, we'll go right here. Let me get going. And I am looking for 3059. So hang on just a second here. Okay, so here we are, and our first order of business is to graph. And I'm going to do a pretty rough graph here. So we've got 1 over t. We're going to go and I've got 0 and 2, 4, 6, 8, 10, and 12. Here I have 0, 0.5, 1, 1.5, 2, 2.5, and 3. So 3 and 12. Let me go up to 12 here and 3. There's my first point. My next point is going to be right underneath 1.5. And then I'm on 4. Whoopsie. Right here, 1.5. Then I'm on 4 and 1.5. Then I'm on 5.5 and a little over 1.5. I'm on 6 and 2. I'm on 8 and a little over 2. And that's close enough. And you can see this should be a straight line. And we'll have this is 1 over t equals 1 over L, ln of 2 R ext minus RL. This is my rate, or REXT, I lied, in ohms, and this is, I said already, that's 1 over t. Okay, so there is A. So for B, we're asked to find the slope. That'll be found by 2.20 s to the minus 1 minus 1.86 s to the minus 1. And let's do 8 ohms minus 6 ohms. This will equal 0.17. Okay, and the slope, what else we want? The self-inductance. Resistance, slope, and then self-inductance. And then finally the resistance in RL. Okay, so now the self-inductance will be 1 times L, ln of 2 equals 0.17. We can solve this. L equals 8.48. And then the curve in part A tells us that R this is the y-intercept. So RL over L times the ln of 2, 1.1 s to the minus 1. Solve for RL, that'll be 1.1 s to the minus 1 times 8.48 times the ln of 2, and RL will be equal to 6.46 ohms. Okay, so L is this, and there's R. Okay, now let's do C. Not as bad as I thought this was going to be so far. Then the energy stored in coil. And the power dissipated. Okay, so our energy will equal 1/2 Li squared, 1/2 times 8.48 H times 20 amps squared, and this will equal 1696 joules. And then our power equal I squared times RL, and RL was 6.46. Okay, so PL will equal 20 amps squared times 6.46 ohms, and that will equal 2584 watts. And I believe we are done.